Hello everyone, welcome back to my YouTube channel. In this video, we will try to understand what is meant by the jobs in PySpark. I will go through all these questions like what is meant by the jobs in PySpark, how and when the job gets created, how many jobs created for a particular code, and few interview questions. So we'll go through one by one. Okay. So the first thing is to understand what is jobs. To understand it, we have to understand the execution plan of PySpark. So let's suppose this is our Databricks notebook. Okay. In this you have written some set of codes. Now when you run this codes using Spark submit command, it will create an application internally. It will treat this entire code as an application. Then our driver will divide this application based on some logical units known as jobs. Job 1, job 2 and job 3. Now you must be wondering what are those logical things based on which it divides one application into multiple jobs. So those logical units are known as actions. So in PySpark, if you are using any of the action, it will create a job out of it. So in simple terms, we can think of if I'm using one action function in my notebook, then I will have one job in my execution. Okay, same if I'm using 4 actions in my code, I will have 4 different jobs in my Spark UI. Okay, so each action equal to each job, one job you can say. Okay, now this job again will be further subdivided into stages. I will not explain much on these topics. I will not focus much on these topics, the stages and the subsequent layers. We'll cover these topics in the next video. But just to give you an overall picture how execution architecture works in the Spark, I am showing you this diagram. So the job will be divided into the stages and each stage will be divided into the task, which are your actual or the smallest unit of execution. Okay, these tasks are gonna execute on the nodes for different executors. Okay, so as of now let's focus on the jobs only. As I said, each action will create a job in your PySpark notebook. So now I think it is clear what is the meaning of job in the PySpark. So the job is a logical unit of a application which will be executed in a separate thread, you can say. Now when and how does the job created in PySpark? As we know, each action creates a job. So if there are 4 actions in your code, then it will create 4 jobs. How to check how many jobs are created? We already gave this answer. So let me quickly switch over to the PySpark notebook and I will show you all these things in a practical implementation. So the first line of code is schema creation, where I'm creating a schema, then I'm creating a data. I'm creating a data frame here and I'm using create data frame function. Okay, now this create data frame function works as an action. Okay, so since it's an action, it will give you one job. Now to see if my current data frame has or what is the physical plan of this data frame, what I can do is I can use one of the function given by PySpark known as df.explain. This explain will explain you like how many forgot to add the brackets. So if you see in the physical plan, we have one job created, which is for this RDD or a data frame here. Now let's say if I wanted to perform another action on it known as account, if I run it, it will create two jobs now, right? One for create data frame, another one for count. Okay, so if I go inside it, let's say job 8 and job 9, any one of them, you will see a shuffle happens because we used count function. What count function do is it will go and collect the data from different partitions and try to give you a count. Whenever you use a count function, you will definitely see this shuffle. Okay, we'll talk about what this shuffle is in a detail, but this is called shuffle. Okay, now this is stage 11 and this is your stage 12. Okay, this is job 9. The status is succeeded when we have executed, how much time it took. These all information you can get it from here, and you can also see a stage for this particular job, job 9. Okay, now if you wanted to go inside the physical plan and if you wanted to see the physical plan from the UI side, you can use SQL data frame. Inside SQL, this is the job you have, right? 8 and 9 corresponding to these jobs. Click on the description and you will have your plan here, details. It will give you the entire physical plan of your code. Okay, I will explain you how to read it, but as of now, make sure you are reading it from the bottom. Okay, it's always starts from the bottom. Okay, now this plan is nothing but it is depicting the same DAG which we have seen earlier. Okay, this DAG. Apart from this physical plan, you can also see the actual execution over here. Okay, so if you see, my first job got created here and my second job got created here. These are the two jobs which got created. Okay, now after this, my last question was, let me scroll up, what is catalyst optimizer? To give you this information, or to give you the information of Spark pushdown predicates, let's look into another example. Okay, yes, we have to go through these two more examples to understand more on the jobs and on these two topics. Okay, so let's move to the next example here. In this example, I have a schema. Okay, and this time I'm creating a data frame based after reading a file. Okay, now just to let you know guys, this read function works as an action. So if I run this code, and after this code, if I run explain, it will tell me that there is a job now. And why this job is here? Because of this particular read function. Okay, okay, so this is our first job. So reads work as a action. Okay, now if you wanted to check again, what you can do, you can use display. As soon as you will hit on this, you will see two jobs got executed or has been shown. The first job is for your read statement and the second job is for display, because display will also work as a action only. So if you see, this time there is no shuffle because we didn't perform the count operation. Okay, but you see there is a stage. Okay, because of this display. Now inside it again you will see two job IDs for this display. Okay, so the first one is while creating a RDD, okay, using the read, and the second one is the collect. This is the physical detail, scanning RDD, and then collect operation which actually works inside display. Okay, so let's move to the third example now. In the third example, if you see, I am not passing any schema, right? So what it has to do, it has to create his own schema by scanning this entire data set. So first operation it will do on read, the second operation on the schema side. Okay, so let me remove this filter and let's run this code. See, I'm giving you these examples so that you can see the difference while using actions in the job. Okay, how the job counts are increasing and decreasing. So it's done. Okay, and if you see, it created one job out of it, right? Based on this particular data frame. So it's created a job. Okay, I don't know why, but this is the 12th, right? Job 12. Let's go again. Think I have seen something different. Okay, so now we can see there is only one job, right? Job 12. And for this job, we have, this is our physical plan and this is our logical plan. Okay, and we have only one task inside it. One job, one task. Okay, now let's change this code again. So let's say in my df7, and from the df7 I'm doing a filter, and then I'm storing it in df12, and then I'm displaying the df12. So again I'm performing one operation, filter, and then after filter I'm performing another operation, display. Right, we have seen on top of it also, when we are using display, one task gets created. So as of now only one task, now it should create three tasks, right? So let's run it and let's try to, column 3 cannot be resolved, my bad. Let me see what is the column name then. df7 limit 1. Okay, since I didn't give any schema, that's the reason I don't have any column 3. But what I will do, I think this underscore c2 will have this value. Okay, so let's see if that works. We run this command again, it will create another job. So if you see, with each execution you see the job numbers are getting increases, right? Because Spark will actually creating a, or actually maintaining this entire history inside it. Okay, now if you see, there are three jobs created. Why? The first one is for read, the second one is for filter, and the third one is for display. That's the reason you will see three different tasks inside it. Each task will have one stage which is already being succeeded. So now if you see here, I have used the filter command. Let's go to the physical plan and see how this filter works. Okay, okay, I'll move to the physical one. So as I told you, if you wanted to read this physical plan, always start from the bottom, right? Correct. So if you start from the bottom, what it's doing, it's scanning the CSV. It means it's taking the CSV file, it's creating a data frame out of it indirectly. Okay, see, this data frame got created, and inside this data frame, you see, after that, in the physical plan there is a filter, but in the actual plan, if you see, in this actual plan. Okay, this is a physical plan, but if you see the logical plan, the execution plan, you will see in memory file index it is actually pushing the filter down. So instead of reading this entire file, first it is pushing this filter and trying to filter out the data directly there, so that later on there won't be any problems, right? Correct. So this is called basically here push down predicates. So Spark optimize its code its own by pushing down its predicate functions. So filter is like a predicate function. Okay, now this filter will be applied first and then it will retrieve the data. That will save some cost as well as it will improve the performance. Now this activity is being done by Catalyst Optimizer, which is actually optimize your physical plan. So I hope all these questions are answered now. So let me revise it again. What is Catalyst Optimizer? It will use, or it basically used by Spark to optimize a physical layer, physical plan, execution plan. What is push down predicate? If you have any predicate used in your code, it will be pushed down at the lowest level so that your performance will be increased. This change will be done by Catalyst Optimizer. Is read function is an action or transformation? Now you can easily give this answer, right? A read function is an action. Okay, always remember, it will always create a job. Interviewer can ask you how many jobs will be created. Now you can check the number of actions in your code, and based on the actions you can justify, like it will need 4, 5, 6, 7, and how many jobs are there will be there, right? And these are the basics one which we already covered. So I hope this video will help you guys. In the next video I will explain what is stages and what is task. Okay, so thanks for watching this video.